The subcommittee on space will come to order. Good afternoon. Welcome to today's hearing entitled Next Steps in Human Exploration to Mars and Beyond. In front of you are packets containing the written testimony, biographies, and required truth and testimony disclosures for today's witnesses. Before I begin, I do want to take a moment to express our thoughts and prayers on behalf of this committee for those in Oklahoma who have just gone through the recent tornadoes. As Americans came to their fellow Americans in aid for Hurricane Katrina, Superstorm Sandy, we expect nothing less from us in our friends' time of need. I'd also like to, I recognize myself for 5 minutes for an opening statement. I would also like to take a moment and remember astronaut Sally Ride, the first American woman in space, who was honored last night at the Kennedy Center for her tireless work promoting the nation's space program and her devotion to STEM education for our nation's children. Over the last decade, the human exploration program at NASA has been plagued with instability from constantly changing requirements, budgets, and missions. We can't continue changing our program of record every time there's a new president. This committee is consistent and unwavering in its commitment to human exploration, a tradition that I'm confident will continue into the future. Congress issued steady guidance in the 2005 and 2008 Authorization Acts that directed NASA to base exploration progress on availability of funds. In accordance with the Authorization Act of 2010, NASA is developing the most powerful exploration vehicle and advanced crew capsule since the Apollo era. The SLS and Orion will take our astronauts deeper into space than ever before. I am committed to the success of these assets and ensuring their continued on-time development and appropriate prioritization moving forward. I and many on this committee are frustrated that the administration insists on cutting its funding requests for the SLS and Orion. Reductions in these programs make me question the administration's sincere commitment to their success. If nothing else comes out of this hearing, I hope it is clear to those inside and outside the administration that this committee is devoted to human exploration, and we intend to ensure this year's authorization reflects that commitment. Numerous studies and commissions have provided Congress with recommendations for purposes and goals for exploring space. We don't need another study, we need action. As we move forward in the next few months with the NASA Authorization Act, Congress must address our path to Mars and beyond, so there will be no question as to where we are headed and how we will get there. As we venture further into the solar system, there must be a plan in place for the capabilities, skills, and technologies needed to land humans on Mars and return them safely to Earth. Today, we will discuss the best way to take our first steps toward Mars and the path we should follow to get there. The two most commonly referenced possibilities for next steps are an asteroid mission and a lunar mission. We have a panel of experts with us today that will be able to speak to both of these options. The last three NASA Authorization Acts have created a clear legislative record supporting a return to the moon, with a sustained human presence as a training ground for venturing further into the solar system. There are many advantages to returning humans to the moon, and I look forward to hearing from our witnesses today about what we may gain from a return to the surface of our closest celestial neighbor. Additionally, this year the administration proposed to capture an asteroid and move it to a nearby orbit as technology demonstration and exploration training opportunity. Prior to this year, NASA has not presented Congress with any indication such a mission would be in development. I still have many questions about the budget profile, technical plan, schedule, and long-term strategy, as NASA has yet to even complete a mission formulation review. I am not convinced this mission is the right way to go and that it may actually prove a detour for a Mars mission. Today, we have one of the scientists who wrote the study which became the basis of the asteroid mission, and I look forward to hearing his thoughts. Human exploration has always had its challenges, but the United States has always risen to the occasion. This country was built by people who dream big and do hard things. I believe the decisions we make today will determine whether the U.S. maintains its leadership in space tomorrow. In the future, as in the past, I hope we will be able to focus mission priorities and goals to ensure our best chance of success. Of course, if I may, I would just like to introduce my friends with the partners with Stennis who are here. I know several of y'all may be with the Citizens for the Exploration of Space. Thank y'all for being here. And it was great to have a little tongue twister while you're in the audience. And just say, call it moon. Why don't we just do that? Lunar. Okay, I got it. I now recognize our ranking member, the gentlelady from Maryland, Miss Edwards, for an opening statement.
Well, thank you, Mr. Chairman, and good afternoon, and welcome to our distinguished panel of witnesses. I really appreciate, Mr. Chairman, that you called this hearing on next steps in human exploration to Mars and beyond. I have to say I don't know what the rest of Congress is doing, but this subcommittee and our full committee have been quite active in our oversight. We've held hearings recently on near-Earth objects, exoplanets, as well as previous hearings that we've held on Mars and planetary science. And these issues have only deepened my enthusiasm for what NASA does and whetted my appetite for the places that our astronauts, our humans, might explore in the future. Human exploration is indeed a big part of NASA and its inspiring mission. It's also an important catalyst for advancing our nation's innovation agenda and for demanding the types of skills and educated workforce that contribute to our nation's economic strength. I want to ensure that others share my enthusiasm and excitement and one day experience the thrill, the absolute thrill of American astronauts, of humans traveling to and exploring a surface far beyond our Earth and then returning safely home. That's something that the United States of America has not done in 4 decades, and I don't want another 4 decades to pass before we explore deep space again. That's why I'm delighted to hear the NASA Administrator Charles Bolden speak more often, more recently, about Mars as an ultimate destination, at least in the next 20 years, for human exploration. Today's hearing will examine potential interim steps en route to that ultimate destination. Successive NASA authorization acts have authorized a stepping stone approach to human exploration. The Moon, near-Earth asteroids, and other points are among the destinations that can be considered to help prepare for eventual human exploration of Mars. The administration's recent proposal to capture a near-Earth asteroid, bring it into translunar lunar orbit, and to potentially send humans there is yet another possible step. But before we look at interim steps, we need first to understand what it takes to get to Mars. Learning how to deal with extended space travel, protecting ourselves from harmful radiation, and surviving on another planet are a few challenges that come to mind for humans. Is there a plan to get there and to address these and other challenges? What should Congress expect to be included in a credible and measured roadmap to achieve the goals of sending humans to Mars? Such a guide can help us determine whether one or more interim steps make sense, and which one, how an interim destination would move us forward along the roadmap, and which destination or destinations are most effective in enabling progress towards a Mars goal. We have an impressive group of witnesses here today, Mr. Chairman, with deep expertise in these issues that we're discussing. And so I thank you for joining us, and I look forward to your testimony and to learning from you. And with that, Mr. Chairman, I thank you, and I yield the balance of my time.
Thank you, Ms. Edwards. I now recognize the chairman of the full committee for a statement. Mr. Smith.
Thank you, Mr. Chairman. Human history is punctuated by great advancements in the exploration of the world around us. We have long sought out the next frontier, which may well be the exploration of our solar system. No doubt humankind will continue to push the boundaries of the known universe. Not long ago, the exploration of Mars was considered science fiction. Today, with 2 active Martian robotic missions ongoing, it is no longer science fiction at all. Space exploration goes beyond rockets and avionics. It is about hope for the future. Human spaceflight represents the aspirations and ambitions of the American people. Few sights are more inspiring than when a rocket lifts off a launch pad and disappears into the sky. Investments in the Space Launch System and Orion crew capsule manifest the ingenuity of the American people and the next steps in space exploration. Neil Armstrong and Buzz Aldrin transfixed America and the world when they landed on the moon in 1969. The Apollo program was proof that we are not permanently tethered to our home planet. It was a reminder that humans will always be explorers. As our space program prepares for the next step to Mars, Congress must ensure that there is a strategic plan in place. NASA should have a well-thought-out and convincing plan before committing scarce resources. The trip to Mars will not be a direct one. We will need to train for it before we send a crew, much like the Apollo missions. One option for training would be a set of lunar missions. Congress has a long history of support for lunar landings and exploration. To me, there is no better way for our astronauts to learn how to live and work on another planet than to use the moon as a training ground. Another option presented by NASA this year is an asteroid retrieval mission. It is difficult to determine what advantages this may offer without a plan to evaluate. The administration originally proposed a mission to an asteroid in deep space. A recent National Research Council report found little support for the proposal. Without a consensus for the original plan, NASA haphazardly created a new asteroid retrieval mission. Unfortunately, NASA did not seek the advice of its own Small Bodies Assessment Group before presenting the mission to Congress. If NASA had sought the advisory group's advice, they would have heard it was, quote, entertaining but not a serious proposal, end quote. Maybe that's why they didn't ask. As this committee begins to draft the NASA Reauthorization Act, we must be mindful of the impact it will have on the future. The policies we put in place today will affect our capabilities many years from now. Thank you, Mr. Chairman. I'll yield back.
Thank you, Mr. Smith. I now recognize the ranking member of the full committee for a statement. Ms. Johnson.
Thank you very much, and good afternoon. I'd like to join the chairman and ranking member Edwards in welcoming our witnesses today for today's hearing. It is a distinguished group of experts, and I look forward to their testimony. The topic of this hearing is an important one, as it touches directly on the future direction of the nation's human exploration program. I expect that it will be a lively discussion, and that it is it really should be, because it just gives us further evidence that NASA space exploration activities, both human and robotic, matter, and thus worth discussing, maybe even arguing about. As my colleagues know, I have long been a supporter of human exploration. It pushes technological innovation, advances our understanding of the universe, challenges our best and brightest, and inspires millions of our young people. It also is a very visible symbol of our commitment to the very peaceful commitment to our outer space. In fact, it's not an exaggeration to say that NASA and its programs provide one of the most positive images of the United States abroad, and that's as much as we could hope for. Yet it is evident that despite clear policy direction and successive NASA authorization acts, NASA's human exploration program still has an air of tentativeness about it. For example, the International Space Station, which I strongly support, is currently the linchpin of our human exploration and space flight program. However, we still lack a clear picture of the ways it will be used to advance the nation's exploration goals. In addition, the Space Launch System and the Orion cruise vehicle are transportation systems that will be needed for whichever path we take in our human exploration program. Yet they currently are being funded at levels significantly below their authorized budgets and are being forced to make progress under a funding profile that is anything but typical of the challenging development programs. If they are essential to the success of the exploration program, then their priorities should be reflected in the resources they are given. Finally, of course, if our nation's exploration program is to succeed, we need to have a clear roadmap to follow. That, too, is lacking at present. Mr. Chairman, we can criticize NASA. We can criticize the current or previous administrations. The reality is we also need to look at our own actions. I believe that many of our colleagues see the benefits, both tangible and intangible, that we have reaped from our past investments in NASA. And successive Congresses have directed NASA to undertake an exciting and inspiring initiative of human exploration of our solar system, with Mars as an obvious and challenging goal. That is as it should be. It is a goal worthy of a great nation that we are, and one that will lead to good things for our country, even if its attainment winds up taking longer than some of us would like. Yet, at the same time, we appear to be unwilling to make the investments that NASA will need to make it if it is to succeed. And we are even failing to deliver the funding we do provide on any kind of predictable basis. This is unfair to the hardworking men and women of NASA and its contractor team, and it is unduly increases risk and winds up costing us more down the road. Yet I'm afraid that we seem poised to repeat that pattern again as we consider this year's authorization and appropriations for NASA. We have just forced NASA to take a significant cut to its fiscal year 2013 budget as a result of sequestration, and some of the House seem prepared to extend those cuts into fiscal year 14 and beyond. If Congress actually carries through with such short-sighted cuts, it will make all of the earnest protestations of support for exploration that we may hear today sound very empty indeed. I hope that as we prepare to move forward with our NASA reauthorization, this committee at least will make sure that NASA has the resources it will need to carry out the very challenging task that this nation has given it. Thank you, and I yield back.
Thank you, Ms. Johnson. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our panel of witnesses. Our first witness is Dr. Lewis Friedman, co-lead of the Keck Institute for Space Studies Asteroid Retrieval Mission Study and Executive Director, Emeritus of the Planetary Society. Our second witness is Dr. Paul Spudis, Senior Staff Scientist at the Lunar and Planetary. Our third witness is Dr. Stephen Squyres, the Goldwin Smith Professor of Astronomy at Cornell University and Chair of the NASA Advisory Council. Our final witness is Mr. Doug Cooke, an aerospace consultant with Cooke Concepts and Solutions. Prior to his current position, Mr. Cooke served as the Associate Administrator for Exploration Systems Mission Directorate at NASA. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which members of the committee have 5 minutes each to ask questions. Your written testimony will be included in the record of the hearing. I'll now recognize our first witness, Dr. Friedman, for 5 minutes.
Thank you very much, Mr. Chairman and members of the committee. It's an honor to be here again. The very holding of this hearing on next steps to Mars underscores the point that human space exploration has a goal and a direction. Mars is the only human-accessible world to study the possibilities of either indigenous past life or potential future life. The Asteroid Retrieval mission, about which I'm talking, and which was first studied by the Keck Institute for Space Studies, creates a first step beyond the moon, the only one that we are now capable of performing, and the only one which we can afford within the current space program budget. This mission represents an opportunity to sustain American leadership in robotic and human space exploration with technological innovation and engineering prowess. While other nations dream of duplicating the American achievement of a half-century ago, the administration's new plan has the U.S. looking beyond the moon on a path that will eventually take humans to Mars later in this century. The new initiative is not a giant step, Apollo-like crash program. Instead, it follows a flexible and cost-effective path using stepping stones into the solar system. The stepping stones are literally and figuratively provided by the near-Earth asteroids. A robotic spacecraft using solar electric propulsion will rendezvous with a very small asteroid in an orbit that is close to Earth's orbit around the Sun. Redirecting that asteroid to the desired orbit in Earth-Moon space will take several years with the highly efficient but low continuous thrust provided by solar electric propulsion systems. The mission will serve as a key technological test for higher levels of power of solar electric propulsion that will be needed for the Moon and Mars. The Asteroid Retrieval mission can be done soon, with a launch perhaps 4 or 5 years from now. It depends, of course, on finding a good target, but this we can do. Hundreds of asteroids this small have already been discovered, although they are hard to see and generally have been ignored, while observers focus on larger objects. Yet we know there are millions of them, and a dedicated observation program will find enough candidates in the right combination of traits for attractive targets for this mission. Increases in the observation program, particularly at the Catalina Sky Survey in Arizona and PAM-STARRS in Hawaii, are expected to increase the rate of discovery 5 to 10-fold in a few years. The small asteroids under consideration for this mission pose no danger to Earth. Even if one did impact, it would burn up harmlessly in the atmosphere. In addition, the asteroid would be put on a trajectory that does not intercept Earth, even if control of that spacecraft were lost. Nonetheless, the asteroid is big enough to be an interesting object to explore. Exploring asteroids is important to understand what they are made of and how they hold together. We may someday have to divert one. Exploring them and discovering new ones is also important scientifically, because these small bodies of the solar system hold vital clues about the origin and history of the planets. Protection and science are two reasons to explore. But these objects offer one more reason for exploration, which intrigues many now, and that is prospecting and the potential for possible commercial utilization. The feasibility of the asteroid retrieval mission caught some in the space community by surprise, but the use of solar electric propulsion technology, the capture of non-cooperative objects in space, the discovery of near-Earth objects, and the application of the clever techniques of celestial mechanics that make up this mission are all developments that NASA and other space agencies have been working on for years. The asteroid and lunar orbit may be the first stepping stone on the flexible path to Mars. Asteroids and Sun-Earth Lagrangian points could be the next. Then an asteroid further away, closer to Mars. Then a Martian moon. And then Mars itself. I believe this is the direct and only sustainable way to Mars. This project will not just unify NASA with science, technology, robotic, and human components, but will unify many others globally with a great adventure. Europe, Japan, Russia all have asteroid mission plans and solar electric spacecraft in operation. They could join in the mission development. After the asteroid is in place, even private spacecraft developers could be invited to explore and test new prospecting ideas there and maybe create a new commercial industry for utilization of space resources. Meanwhile, NASA again will be leading the world into space, moving on to new accomplishments on more distant asteroids, perhaps on the Martian moons, and then on Mars itself. Thank you.
Thank you, Dr. Friedman. I now recognize our next witness, Dr. Spudis, for 5 minutes.
Thank you, Mr. Chairman. I thank the chairman and members of this committee for this opportunity to share my thoughts on the appropriate next steps for human exploration of space. The past 50 years have witnessed an enormous accomplishments from our national space program. We've surveyed the entire solar system and launched hundreds of spacecraft, making us more knowledgeable, prosperous, and secure. Despite this history of accomplishment, we lack a clear long-term direction forward, and our space program is withering away. To find a sustainable path forward, we must consider the utility and purpose of human spaceflight. Although much can be accomplished in space using robotics, many tasks require the presence of people who combine high-level cognitive abilities with intricate manual dexterity. I believe our long-term goal should be to possess the ability to go anywhere we choose in space, to do whatever job or study we can imagine. Such capability requires an affordable, extensible space transportation system, one built incrementally over variable timescales to prevent fluctuations in funding from preventing its completion. One can imagine two very different approaches to spaceflight. One conducts a public spectacle, a one-off flags and footprints mission to some new and exotic destination. The other approach uses incremental yet cumulative building blocks that enable the gradual extension of human reach beyond low Earth orbit. The former produces a media event, while the latter links capability with progress and creates lasting value. A transportation system that can access the lunar surface can also access all other points of cislunar space, the domain of nearly all the world's satellite assets. The experience of building International Space Station and the servicing missions to the Hubble Space Telescope have demonstrated that people and machines working together in space can accomplish much more than is possible through the launch of smaller, custom-built expendable spacecraft. Our current template of design, launch, use, and eventual abandonment of space-based assets can be transformed into one of building and maintaining large, extended, and distributed space systems of unprecedented power and capability. This capability will produce enormous economic and societal return. It will create new wealth, not simply consume it. To achieve these ends, I believe that a return to the moon to access its and use its material and energy resources is the next best step for human spaceflight. The moon is important for 3 reasons. 1, the moon is close. It is easily and constantly accessible, while its proximity permits early development before human return using robots remotely controlled from the Earth. The moon is interesting. It retains a unique record of its own history and processes, as well as those of the Earth-Moon system, the Sun, and the galaxy. This record gives us insights into the past and future of our home planet. But most importantly, the moon is useful. Its material and energy resources can break the logistical chains of the Earth. Several recent missions have discovered and confirmed abundant water at the lunar poles, all close to locations of near-permanent sunlight. This relationship enables our long-term presence on the moon, where we can extract water for use as life support consumables, energy storage, and most significantly, to manufacture the most powerful chemical rocket propellant known, hydrogen and oxygen. Water, oxygen, energy, and rocket fuel are vital enabling assets, provisions that will not have to be launched from the surface of the Earth, the deepest gravity well of our solar system. Harvesting these resources from the moon creates our first off-planet coaling station in space. We are not capable of sending humans to Mars now or in the near future in either a technical or a financial sense. We need a cohesive intermediate goal, one with specific scalable activities and benefits that help assemble a permanent spacefaring system, a system that will open the way to Mars and to all the planets. The moon affords us this opportunity and the incentive to create such a system, a transcontinental railroad in space. Included with my submitted material is an architecture showing how we can incrementally and affordably develop this system. We went to the moon in the 1960s to prove that it could be done. We returned to the moon 50 years later to prove that we can use its material and energy resources to create new capabilities and commerce. A cislunar transportation system, developed and powered with lunar resources, will extend our reach into deep space and revolutionize the paradigm of spaceflight. This effort is not been there, done that. It is a wholly new, untried, and necessary pioneering enterprise in space. I thank the committee for its attention. I welcome your comments and thoughts, and I'm happy to answer any questions you might have.
Thank you, Dr. Spudis. I now recognize our next witness, Dr. Squyres.
Thank you, Mr. Chairman. Mr. Chairman, members of the committee, thank you for the opportunity to appear today. The topic of this hearing is the next steps in human exploration to Mars and beyond. My recommendations to the committee today are as follows. First, affirm that Mars is and will continue to be NASA's long-term goal for human exploration of space. Second, at all future milestones on the road to Mars, direct the agency to focus on activities that clearly serve the goal of landing humans on Mars, operating there, and returning them safely to Earth. Third, adopt cislunar space as the next milestone, whether ongoing studies show that it's possible to redirect a small asteroid there or not. Finally, dictate no milestones beyond cislunar space without first assuring ample funding to achieve them. I'll address each of these in turn. The NASA Authorization Act of 2010 stated that a long-term objective for human exploration of space should be the eventual international exploration of Mars. I agree. In fact, in my view, Mars should be the long-term objective for human exploration of space, whether carried out internationally or by NASA alone. Alone among the planets, Mars is enough like Earth that we can imagine life once taking hold there. There's a vast and growing body of scientific knowledge that shows that the Martian surface once possessed many of the essential ingredients that are required for life. So sending human explorers to Mars to learn whether life ever emerged there is a goal that is worthy of a great national space agency. The most useful milestones on the way to Mars are ones that, when met, help retire risks that will be faced on the way to the Martian surface and back. In the 1960s, we didn't go to the moon all at once. Instead, the capabilities to land humans on the surface of the moon and return them safely to Earth were built up systematically over a series of Mercury, Gemini, and early Apollo missions. I'm convinced that the even more challenging capabilities that will be necessary to achieve a similar goal at Mars must also be built up stepwise. And at each step along the way, it will be crucial to examine all of the activities that might be conducted critically and pare them down to the minimum necessary to assure progress towards Mars. Many of the most important capabilities that are going to be necessary for human missions to Mars can be developed in cislunar space. This work can be done far enough from Earth that progress towards a true deep space capability can be demonstrated, but close enough to Earth that a safe return in the event of an anomaly is facilitated. Moreover, given the performance capabilities of the Space Launch System and the Orion crew capsule, cislunar space is the only significant destination below low Earth orbit that can be reached for the foreseeable future. It's the sensible next step simply by process of illumination. And I reach this conclusion whether NASA's ongoing efforts to study redirection of a small asteroid to lunar orbit bear fruit or whether they do not. After cislunar space, the choice of the next milestone becomes more difficult. Personally, I'm not persuaded that any physical destination like the lunar surface, an asteroid, or a Martian moon is truly necessary to get to Mars, function there effectively, and return safely. Others on this panel may disagree. But while we can debate the relative merits of such destinations, my most important message to this committee today is that I believe that no realistic step beyond cislunar space should or can be usefully identified right now. The fundamental barrier to making an intelligent choice today is that NASA is being asked to do too much with too little. This overtaxing of the agency is chronic, it's severe, and it's getting worse. It's manifested clearly even in NASA's near-term plans. To be more specific, the current development schedule for SLS and Orion calls for a flight rate that's so low that I believe it's a cause for serious concern. In a fiscal environment where even the next step to cislunar space cannot be carried out at an adequate pace, I feel that for Congress to dictate any subsequent milestones today would be unwise. Unless NASA's funding is increased substantially, any attempt to specify milestones beyond cislunar space today would amount to an unfunded mandate. And if NASA is directed to do something it is not funded to do, I predict that the result will be wasted effort and a delay in achieving the ultimate goal of humans to Mars. I'd like to conclude my opening remarks today on a positive note by pointing out that the solution to the mismatch between NASA's aspirations and its budget may be international partnerships. This was the case for establishment of a permanent Earth-orbiting laboratory, and the International Space Station that resulted is a magnificent example of what space agencies can accomplish when they work together. If no major funding increase for NASA can be found, then I believe that the agency should aggressively seek out international partners for the human exploration of Mars. But if that happens, I feel that neither Congress nor the administration can expect to dictate what the next milestone after cislunar space should be unilaterally. Instead, that milestone will have to be negotiated fairly and equitably with those international partners. Again, thank you for the opportunity to appear today.
Thank you, Dr. Squyres. I now recognize our final witness, Mr. Cooke.
Thank you, Mr. Chairman and members of the committee, for the opportunity to discuss this exceedingly important subject. I strongly believe that an enduring long-term strategy for human spaceflight should be developed now with the carefully defined missions that significantly contribute to long-term goals. This strategy does not exist today. Once developed, national will is crucial to sustain this strategy with budget stability. Otherwise, we may watch other spacefaring nations pass us by when the United States should have led the way. We first need to address the questions, initially without regard for specific budgets. What are the geopolitical goals that we want to achieve with human spaceflight? What is this country's long-term vision for future human space exploration? And how do we collaborate with international partners to achieve this vision? If crafted properly, an organized process would obtain and prioritize the exploration objectives from a spectrum of stakeholders. The strategy would then address appropriate objectives for each destination, including those for advanced scientific discoveries, development of critical technologies, and preparing for Mars exploration and others. A widespread advocacy for the strategy would occur with stakeholder participation in the process. There is a broad international consensus that Mars is a human exploration destination that we should ultimately aspire to. To develop the strategy, we should ask what is needed to send people safely to Mars in capabilities, technologies, human research, etc. A preferred path can then be chosen through a series of carefully selected missions and destinations that most effectively address these exploration goals and objectives. Regardless of the actual sequence of missions, the current development of the Space Launch System, Orion MPCV, are critical to success of the strategy. This strategy must be flexible with the anticipation that it should be responsive to discoveries, budget realities, and emerging technologies. Asteroids are certainly a very interesting object for scientific study. They can provide information on the formation of our solar system, and cataloging them is important to understand their threat to Earth. The current President budget request included a challenge to retrieve an asteroid, move it to nearer space, and to be investigated by astronauts. It is a clever concept, and such a mission would undoubtedly demonstrate technology and capabilities. However, there is not a recognizable connection to a long-term strategy. It does not appear to be based on consultation with stakeholders, nor are there visible opportunities for international participation, although I am told these are in work. It appears to be a very complex mission with the potential for growing more complex and more costly. As currently defined, the mission definition does not convey a mature concept that should be supported with significant funding without further understanding of its value to long-term human exploration strategy, competing with other mission destinations. I believe that robotic missions are currently a more cost-effective way to study asteroids. In preparing for Mars, the next generation of explorers must learn how to survive in other hostile environments. The Moon is an alien world with partial gravity like Mars, yet is only a 3-day journey from Earth. Human lunar exploration will provide opportunities to test technologies to experience living and working on another planetary surface, to use lunar resources, and to identify commercial opportunities. The moon is a truly unique nearby destination where scientists can learn about the history of the inner solar system over the past 4.5 billion years. We now have incredible new information derived from recent robotic missions, LCROSS, LRO, and GRAIL, that can help guide further lunar exploration. I believe the United States should provide leadership in exploring the moon as an important step in any long-term exploration strategy. Relevant near-term missions to Mars may be closer than previously thought. For instance, the mission proposed by Inspiration Mars, while I think is very challenging, may provide such an opportunity. More difficult, but on the order of what would be needed for a mission to one of the more difficult to reach asteroids, a mission to the fascinating moons Phobos and Deimos are possible. Mars surface exploration is the ultimate goal that can be reasonably envisioned today. I propose that the following steps be taken to develop a unified and enduring U.S. human space exploration strategy. Conduct an open process including stakeholders to develop the strategy and exploration objectives. Reestablish lunar exploration as a valued near-term part of the strategy. Identify other near-term mission opportunities that most effectively contribute to long-term exploration goals. Identify opportunities to combine resources and capabilities with international partners to achieve these objectives, and endeavor to ensure U.S. leadership in human space exploration. Once again, I thank you for inviting me here to give my views. I also want to thank this committee and the subcommittee and your staff for continued bipartisan support for human spaceflight. I welcome your questions.
Thank you, Mr. Cooke. A vote has been called. The committee will recess until 10 minutes after the last vote. The committee stands in recess. The Subcommittee on Space will come back to order. I want to thank again the witnesses for being here, being available for questioning today. I also want to remind members that committee rules limit questioning to 5 minutes. The chair will at this point open the round of questions. The chair recognizes himself for 5 minutes. Mr. Cooke, Congress has consistently affirmed that NASA should develop an exploration architecture to go to the moon, Mars, and beyond on a timetable determined by available funding. NASA receives roughly $17 billion a year, and approximately $3.5 billion of that is devoted to exploration systems and support infrastructure, and even more under the previous administration. Last month, the NASA administrator indicated that we cannot return to the moon because NASA does not have the funding to do so, arguing that NASA has no money for a lunar lander. My question is, could NASA establish an exploration architecture and development profile that could accommodate a lunar architecture under the current funding profile? This schedule is not a driver.
There are a couple of factors that I'd like to bring up. One, the existing profile is a flat profile, as I understand it, still with no inflation, which is problematic. So I think the situation would be improved if there were even inflation. And I think we were seeing that back when I was at NASA. I think NASA can definitely put together architectures that fit a funding profile. We've done it. We've always done it. I guess the question I would have is if an asteroid retrieval mission is going to cost $2+ billion, according to the Keck study, where is that money coming from? Is that new money? If it's not new money, it's coming from somewhere, and so is it coming out of existing human spaceflight programs? Is it coming out of technology? And if $2 billion+ is available, could it be better spent? Could it be better spent on an upper stage for SLS that brings it to full capability, or could we partner with internationals to develop, collaborate and develop a lander for the moon? If we have a long-term exploration plan, as I was making the plea for, you can understand how those things fit into it and what's the best expenditure of funds. So I don't know specifically what the plans are and where the money is coming from for the asteroid retrieval mission, but it seems that an alternative would be to put that money toward lunar exploration.
Do you believe it is necessary to develop a lander in parallel with the development of SLS and Orion, or could the lander be developed at a later date?
I believe that in everything that we do, we phase our spending. And in fact, even in the SLS program, as we initially laid it out in 2011, things were phased. We chose the components that we did. We knew we had to get a core stage built, which was new. Every choice that we made in terms of the engines and boosters and that sort of thing were phased in order to fit under the funding profile. So that is something that's always done, is you phase your developments to fit under that line. So certainly as some of the costs come off of development on a rocket, or if efficiencies are found in space station operations, for instance, money like that could then be phased into development of lander. It doesn't have to be at the same exact time. We phased money and spending to develop as we could, and so driving towards your point, you can phase your developments within a funding line to achieve long-term what you're looking to do.
Now, exploration systems architecture study has considerable international input. The witnesses before us today agree that international cooperation will be necessary for any mission. Understanding that you no longer work for NASA, do you know whether international input was sought for the asteroid retrieval mission?
I am not aware that it was. In fact, one of the concerns I have is that it seems like the process is reversed on this asteroid retrieval mission, where the mission is announced and then you go figure out the rationale and how to partner on it. And so I am not aware or have seen evidence that there was international consultation going into the announcement.
And my last question for Mr. Cooke. The cancellation of the Constellation program was a huge blow to our nation's exploration program and created significant uncertainty for our industry partners. How can Congress ensure that the SLS and Orion are not political footballs in the next administration and are part of a stable long-term plan for exploration?
In my written testimony, I made the point, and I made it briefly in my oral today, that we've looked at various scenarios on what steps could be taken in destinations and missions in achieving Mars landings down the road. The SLS and Orion are critical components no matter what that path ends up being. If we're going to travel beyond Earth orbit, you need that capacity in a launch vehicle, and you need a deep space crew vehicle with the systems designed for those kind of missions that are totally different than what's needed. They're a step well beyond what's needed for to and from Earth orbit, I'll point out as well.
Thank you. I now recognize Ms. Edwards for 5 minutes.
Thank you, Mr. Chairman, and thank you very much to our witnesses. I really appreciate your patience today. I want to start with Dr. Friedman. Dr. Friedman, many of us have had questions about the scientific capability that we gain in terms of an asteroid retrieval mission and how that then contributes to going to Mars. And so I wonder if you could very quickly give us a sense of what the science is that's so different than what we would get from a lunar landing and mission if that were the interim step that was chosen.
Yes, thank you for the question. First of all, it's important to understand that, of course, the mission, the asteroid retrieval mission, wasn't selected for, or its rationale is not for, science. If it was, then we have a robotic sample returns, and we do missions to asteroids for science purposes. This is part of the human spaceflight program, and its primary rationale is a step for humans to take in space. Having said that, of course, the aspect of what humans could do on an asteroid to delve into the surface, to bring back, to conduct experiments related to future resource utilization, to perhaps drill a little bit, to do experiments related to asteroid science would would contribute greatly not only to the knowledge about asteroids themselves and their relationship to solar system studies, but also to what the structure and composition and strength of an asteroid is and the diversity of them, so that we can someday we might have to deflect one for purposes of planetary protection. So there would be a lot of human-related science experiments on such an asteroid retrieval mission, but it's important to understand that the real reason for doing it is the human capability of being able to go beyond the moon, to be able to go on longer flight time missions, to be able to take larger systems with them for longer life support as a first step beyond the moon, and then to more subsequent larger steps after that.
So thank you. So I'm trying to appreciate then the critical technologies that are necessary with whatever the interim step it is that we choose, whether it's an asteroid retrieval or it's a lunar landing and lunar mission. And so I wonder if each of you very quickly could kind of outline what those critical technologies are, so that when we're trying to figure out how do we make the investment in next step to Mars, that we're investing in all the right critical technologies, whatever the chosen interim destination. And so if we could just kind of go down the line, that would be great.
Well, I think the fundamental one is related to life sciences and life support for human spaceflight once you're outside of the Earth's radiation environment and into deep space. Both the length of the system in microgravity and the radiation exposure are key questions. I think that's the dominant one for long-duration human spaceflight. The other big technology that unfortunately is going to have to wait for more robotic missions to Mars is the entry, descent, and landing on Mars. That's huge. That's an unsolved problem. It's not going to be, you can't learn it on the moon, you can't learn it on an asteroid, you can only learn that on Mars itself. And I think what we're doing in the robotic missions for exploration of Mars is the other key technology. So our electric propulsion technology is a long-duration flight, but that we do know how to do.
So could I hear from the other witnesses whether or not it's a lunar mission or an asteroid retrieval?
Well, one of the key things that you want to develop to go to Mars, in fact to do any kind of planetary exploration, is the ability to solve some of your logistical problems. And that means learning how to use the materials and energy that space have to offer, rather than bringing everything we need with us from the Earth. And I contend that the moon is an ideal place to do this, because it's close enough that we can begin to start doing this robotically with teleoperated machines that could basically pave the way for human arrival later. Now, survival on a planetary all planetary surfaces are hostile. There's no second Eden. There's no second Earth. They're all require us to protect the crew from radiation from the environment and to create our own life support consumables. That can be done on the moon, and that can be done. In fact, a lot of the key technologies we would use there, we would use on a trip to Mars eventually anyway. The other main technological area is learning how to effectively explore planetary surfaces, and that includes using both humans and machines synergistically, so that each one builds on the value on the benefits of the other. That's another experiment that can be done on the moon, because it's a little planet of great complexity. So that's the way I look at it.
Thanks. And could we hear very quickly from Dr. Squyres and Mr. Cooke?
Yeah, just very briefly, I agree with Dr. Friedman that the two most challenging technologies required to send humans successfully to Mars and bring them back are, first of all, deep space life support and habitation, and second, entry, descent, and landing to the Martian surface and ascent. I'll point out that, to me, the connection between particularly the asteroid retrieval mission, which involves proximity operations with a rock that would fit comfortably in this hearing room, I see no obvious connection between that and any of the technologies or capabilities that are required for Martian exploration.
I would agree with most of everything that's been said. I would add that the moon is unique in that it is a planetary surface that has partial gravity like Mars. It has a dust environment that you have to learn to deal with. You can develop surface operational techniques in a partial G environment in spacesuits, learning those techniques and how to explore and how to get the most out of the missions. So we in 2006 we had a conference that laid out objectives for the moon, and there are many of things that you could do there that would contribute to long-term human exploration.
Thank you, Mr. Chairman.
Now recognize Chairman Smith for 5 minutes.
Thank you, Mr. Chairman, and I too want to thank our witnesses today. They've just been excellent in what they've said and their responses to the questions that have already been addressed to them. Several more questions, though, I'd like to ask, and the first one, Mr. Cooke, is addressed to you. This is asking you to speculate a little bit, but I've really not heard anyone answer the question as to why some NASA officials would ignore their own experts, that is those on the small body assessment group, and sort of forge ahead haphazardly with this asteroid retrieval mission. Do you have any idea why they would have chosen to do that?
Well, I don't have any direct information. I'm concerned that it was announced without a process that I outlined earlier.
Yeah.
I think that a healthy process gets inputs from your stakeholders, and in terms of objectives and long-term goals, and that helps you define what missions are. I don't see that that's happened here, and I don't know exactly. I have no first-hand information as to how that occurred.
Other than just a bad judgment call or something like that.
Well, I mean, to me, it would seem that if we're going to go after an asteroid, it would be science objectives, and it's been said publicly that it's not science-driven mission, and so I don't see the stakeholder objectives having driven a mission that you would think would have benefit to science.
Thank you, Mr. Cooke. Dr. Spudis, there are already 2 robotic asteroid retrieval missions by NASA and by Japan, who actually, as you know, retrieved an asteroid in 2010, I think. Is there any more to be gained by an astronaut actually being on an asteroid? And we're talking about an asteroid, literally the diameter of the table you all are sitting on, 7 to 10 meters. And why can't those robotic missions achieve the same goals as an asteroid would? A while ago, Dr. Friedman said, well, an astronaut could drill down into the asteroid, but a robot can do that too. But is there any value added to having an astronaut land on a 7 to 10 foot diameter asteroid over a couple of robotic?
There might be, but it's not clear to me at this stage that there is. One thing that keeps getting overlooked in terms of asteroids is that right now we have roughly 45,000 near-Earth asteroids right here on Earth in the terrestrial meteorite collection. Mm-hmm. And in fact, the largest one is a meteorite named Hoba, which is 3 meters across and 60 tons. It was found by a farmer digging in a field in Africa and can't be moved because it's too heavy. So we actually have an NEO right here on the Earth right now for study. It's a nickel metal meteorite. Fundamentally, meteorites are fairly homogeneous. That's one of the interesting things about them. Most of the meteorites are chondrites, which mean they're debris left over from the accretion of the solar system. And they have the same chemical composition. They've been heated or not heated to varying degrees. And they're one of the reasons we use them as standards in planetary science is because we can compare planetary compositions to meteorites because they don't vary very much. Now, one of the key assumptions of a human doing field science, either on the moon or on the Earth or anywhere else, is categorizing the diversity and understanding the processes that he's uncovering by sampling. And that's applicable on the moon, it's applicable on Mars, it's applicable on the Earth. It's not necessarily applicable to a homogeneous rock or a homogeneous rubble pile. So the answer to your question is I think we would learn something. No space mission is valueless. But in terms of what we'd actually learn in comparison to a robotic sample return, I don't think we'd learn that much more.
Okay, thank you. And Dr. Squyres, last question. As far as our efforts, if we were to embark upon this asteroid retrieval mission, is there any reason to believe that our looking for a non-hazardous 7-meter diameter small asteroid is going to help us try in our efforts to try to detect larger, more dangerous asteroids that, if they were to impact Earth, could do us a lot of damage? Or is there a better, more direct way to try to detect those types of asteroids?
The kind of search techniques that one would use to find a target for the asteroid retrieval mission will inevitably turn up many, many other objects, some of which will have characteristics that will make them considerably more hazardous to Earth than the target that could actually be deflected and placed, redirected into orbit around the moon. So I believe that one of the truly valuable components of the asteroid retrieval mission is the search for a target, because not only will it conceivably come up with a target that you could actually redirect, but it's inevitably going to find a whole bunch of other rocks that on ensemble may be much more important, both as scientific targets and as objects for future study. But as a threat itself, I think the object you're going to find is, as Dr. Friedman has pointed out, is not something that we need to worry about.
Okay, thank you. Thank you, Mr. Chairman.
Now recognize Mr. Posey for 5 minutes. Sorry.
Thank you very much, Mr. Chairman. You know, so much of what we gain from space every day is unappreciated by the general public. We all know that. And, you know, I just think about the tragedy yesterday. Without the weather satellites, the early warning that we had, how horrible that could have been if it had been more spontaneous, how much more horrible it had been, it could have been. I think it's unfortunate that we don't really have any space plans right now that inspire the general public. For better or worse, the public that I'm familiar with is absolutely, totally underexcited about the prospect of going to an asteroid. And I think we need to have a more robust program. I think I agree with 3 out of 4 of you to make it a national priority. And, you know, funding is always the issue. And funding is the issue because the NASA budget, as small as it is, in comparison to other budgets, is still the biggest piñata. It's the one they go at for totally non-related programs because all the members of this body are not sold on the necessity of it as a matter of return on investment, as a matter of national defense, as a matter of survival for our species ultimately. And my question to the 4 of you would be, how you think we could better move the space message down the field among our colleagues and the general public. If the general public was more excited about it, members of Congress would be more excited about it, and we wouldn't be really limited to underfunding even the smallest possible missions. So we can start with you, Mr. Friedman, going down the line until we run out of time.
Yes, thank you. That's a key question, and it's one that I've worked on my whole career as executive director of the Planetary Society until I retired from that position. Public interest is key. It's actually the thing, more than science, as I tried to say, more than any other aspect that has gotten me so interested in this asteroid retrieval mission. Because even in the last administration, with a full and dedicated commitment to building a lunar program and going back to the moon, the lunar landing, we forget, slipped all the way out to 2028, and that is if the funding had been maintained, which it wasn't going to be maintained. Where would it have been by now? In the 2030s. The joy of the asteroid retrieval mission, the thing that's got me so excited is we actually begin the process in just a couple of years from now. We're going to be looking for the asteroids this year. We're going to be launching the mission to the asteroid in 3 or 4 years from now. We're going to be towing it in an exciting venture that people will be excited about, something never been done in the history of the space program before. We'll be engaging the public in human spaceflight, preparing the target in the way we did with Gemini and Mercury before we went to Apollo. And we'll be achieving human missions to the destination in a much sooner time scale rather than having to wait 2 or 3 decades. I want to get to Mars quickly. I've made that clear. But this is the only way I think that we can engage the public and maybe drive up the money that goes with that.
It's an interesting question because the premise sort of assumes that unless you have an exciting activity, that people won't support something. And yet our society is filled with valuable, critical things that we all agree are needed that people don't get excited about. And so I think really your challenge is to show the public that they're getting value for the money spent. And that's why I believe that building an extensible, reusable system, a spacefaring system that allows us to do all the things we want to do at various spots in space is the way to go. And one way to do that is to go back to the moon and learn to use those resources. That's the way I advocate. There may be other solutions, but fundamentally I think the key thing we need to do to become a spacefaring people is to develop that system. The things that we get from that, the benefits from that, will be self-evident. I mean, right now you mentioned the weather satellites. There's communications. We depend on space assets for many aspects of our modern technical civilization. So what we really seek is public support, not necessarily excitement.
I think that the best way to maintain public support is with an unwavering focus on Mars as the destination. The night that the Curiosity rover landed on Mars, thousands of people turned out in Times Square in New York City at 2 o'clock in the morning just so they could watch it on the big screen. It has captured the public imagination. It has captured public interest. And so I think the best way to maintain that interest is to maintain an unwavering focus on Mars as the ultimate destination and show how each milestone along the way is connected to reaching that destination.
I would agree with that. And the Mars program has done an incredible job of making people aware of what's happening and getting them excited about it. And it's a model, I think, for what we do. I think a key aspect of this is having a plan that people recognize. We don't have one right now, a long-term plan on how to get to Mars. I think we need one with defined steps that are exciting, that we know we'll have achievements that contribute to that ultimate goal. And if we have a wide range of stakeholders, including the science community, including the public, including media, including academia and private industry, as a part of of defining that set of objectives and goals, then you build in advocacy from those groups that also are a part of the plan.
Thank you. Thank you, Mr. Chairman.
I now recognize Mr. Rohrbacher for 5 minutes.
Holy cow. Thank you very much, Mr. Chairman. I'd just like to ask a fundamental question here, because we've been talking about mission to Mars. Okay, mission to Mars and different approaches to mission to Mars and what's the stuff. I'd like to ask the panel whether or not they think a mission to Mars is worth the cost or not. I mean, if we do a mission to Mars, and correct me if I'm wrong, we will have to defund most of the, I mean, if we're going to do it now, start now, and go directly into a mission to Mars, we're going to have to defund, asteroid detection and then deflection. I mean, we might as well forget that. I mean, that's expensive. Debris cleanup, which might, unless we clean up the debris, of course, we may end up having our own use of near space being cut off to future satellites because debris knocking our satellites out of the air. No more GPS, communication satellites, etc. Or how about space astronomy, which we know there's some very important projects moving forward with various telescopes that could give us a really in-depth view of the universe. Unless we think that the tooth fairy is going to leave all the money under the pillow in order to accomplish a mission to Mars, is it really worthwhile the vast expense and the canceling of programs like this in order for us to take off and start heading on a Mars mission now? I'll just go right down the line. That's fine.
Well, thank you, Congressman. You and I have been Mars supporters for a long time, but I think you're quite right in asking exactly that question. Certainly, I haven't heard any of us advocate canceling programs in order to go to Mars right now. I may try to make clear in my statement that we not only don't have the money to do it, but I don't think we have the complete technical knowledge or the scientific understanding. What we're building up with the robotic missions to Mars, what we're building up with taking humans into more complex endeavors in space, but in technical steps has to be done. We go to Mars when we can afford it. I think that's one of the things that has to come out of the program.
And we can't afford it now. Next, thank you for that answer.
You can sort of imagine two ways that you might go to Mars. In one way, you could go to Mars like we went to the moon with Apollo. We design a spacecraft, we develop an architecture, we launch everything that we need for the voyage from the surface of the Earth. An enormously difficult and mind-bogglingly expensive thing to do, considering how much it costs to launch stuff, and you need at least £1 million in LEO to go to Mars with chemical propulsion. The other way that you might go to Mars is to have it be a logical extension of an expanding spacefaring system. So you build it with building blocks. You start with the small pieces that basically access the various spots in Lunar, and then go to Mars when you have that system in place ready to support a Mars mission.
But that is not just saying that we are now going to start. This is our project. We're starting going to Mars, and that's how we're doing
no,
it. No, instead you build it into your existing project.
It's one of the destinations that you plan to.
So I take it your answer to my question is no. We should not start on a way to Mars right now as a project on its own.
Yes, sir.
Despite the fact that I've spent my entire career devoting my efforts to robotic exploration of the surface of Mars, I'm personally a strong supporter of eventual human exploration of Mars. Two reasons. First, humans are far more capable explorers than robots are. What our magnificent state-of-the-art Opportunity rovers accomplished in 9.5 years on Mars, Paul Spudis, who's an experienced geologist, could have done in a good week.
I think we all agree that eventually human beings are going to go to Mars. And we are, because we are on this committee, that we love that vision, and hopefully it may be in our lifetime, maybe, but eventually isn't the question. The question is should we start right now a program at NASA that is engaged in spending significant sums of money that specifically is a man-made Mars mission?
My answer is yes in the following sense, that the next logical step, I believe, on the road to Mars is to reestablish our capability to operate in orbit around another object, specifically the moon, and that is the next logical place for human spaceflight, and I think we should embark on that as soon as possible.
Okay, and that was as part of Mars overall.
To eventually get us to Mars, yes.
I think we can do some of these things without necessarily having the Mars in the background, but as we just heard, building it into a program. What about yourself?
I would submit that we're already on that path in certain ways. It's not necessarily a well-defined path, but for instance, everything that we learned from Mars robotic missions is applicable to our knowledge base that contributes to what we need to know to go to Mars. I would say also that the work that's being done on International Space Station right now in terms of understanding human frailties and how to address those, many of those, and in fact that human research program is aimed at what you need to know about people and their ability to survive in order to go on long missions like to Mars. So I'd say we're already on that path. That needs to be more coordinated and understand the intermediate steps better. And
And would you then suggest that we should be channeling the money out from this asteroid detection and perhaps debris cleanup and or defund for example, the astronomy projects we heard about? You would then be supportive of channeling that money into a direct program that's going to Mars?
I would not stop all these programs. It's a matter of priorities, and we.
That's right. It's a matter of priorities.
And we need to establish, in light of a well thought out, long duration human spaceflight plan that is coordinated with robotic missions and coordinated with these other things, to establish what steps can be taken when. It's not all or nothing, in my view.
Mr. Chairman, thank you very much for having this hearing, and I believe that the last gentleman is right. We have to establish our priorities. And if we try to prioritize something that this day has not come, we're doing a big disservice to the young people who are depending on the technologies that we can put in place right now and utilize if we end up not having the astronomy or the debris cleanup that we need to utilize space, simply because we have mission unaccomplishable in mind in terms of Mars. Thank you very much, Mr. Chairman.
Now recognize Mr. Squyres for 5 minutes.
Thank you, Mr. Chairman. And in some ways, the extension of where Dana was going. All right, let's deal with sort of the reality of our world up here. I mean, we have a government that is being consumed by mandatory spending. Our entitlement state. It's math. It's not political. It's the reality of where we're at. So I come to the four of you gentlemen. You're all brilliant. You all have our expertise. But if you listen to each other, you all have very different visions. If I came to you and said, help us build a box of decision-making with the resources we actually have. I'm not asking you what you think it should be. First, what would you do to analyze saying, this is what resources, this is our timeline? How would you build that decision-making model? Start on my left, and it's more, do I need to put all of you in a room and the last man standing wins? What's the appropriate process here?
Well, if we use that approach, I'm at a big disadvantage, so I'd rather not. I'll try some other one. The mission to the asteroid, which I've been speaking about, doesn't replace missions to Moon or mission to Mars. It's part of a step of technology development and capability in space. The only mission it replaces is the one that was going to empty space, lunar orbit.
Well, let me sort of rephrase my box on the question. It's Marshally, do we actually have both in your opinion, a structure between those of us in Congress, those who are the expertise in space, and NASA, and the exploration world? Sorry, we have a lot of echo coming. To say, here's what we have resources for, here's what's rational within that, here's where we're going technology on the curve, here's how we lay it out.
Without taking into account sequestration, which I don't understand, I think you have the existing program right now could take these first steps and accomplish the SLS, Orion, Asteroid Retrieval, humans to taking a first step beyond the Moon in the existing program.
Doctor?
In order to figure out how to get where you're going, you have to know where you're going to begin with. And I look on it as your job as part of the national leadership to sort of set the long-term strategic direction. How we get there is an implementation decision, and the way you should oversee that. But I don't think Congress should necessarily define it. What you should do is ask for specific technical advice, and then weigh the options, and then make your decisions on that basis. I wish I could say there's some magic bullet that I could give you guys that would tell you instantly, this is the path we need to follow, and there you would be. We all have different views on how to get there. We all want to do that. But my basic observation is that if you craft a program with small incremental steps that all work together, eventually you can build any kind of capability you want under any kind of budgetary environment. Because effectively you're building it with small steps. You're not trying to take big chunks out of it.
Two messages, sir. The first one is that I believe that all four of us would agree that the logical next step is lunar orbit. It is going there to reestablish the capability to operate in deep space and to do the kinds of tasks that are going to be necessary for any of the pathways that we're talking about. So all of us, I believe, agree on the next step, orbit the Moon. Okay? Beyond that, my plea to you, my heartfelt plea is, please do not dictate, please do not mandate another step for NASA beyond lunar orbit unless there is ample funding to pay for it. As I remarked in my opening comments, that would amount to an unfunded mandate, and that is the bane of government agencies. What that would result in, I believe, would be dilution, dispersion of efforts, wasted effort, and eventually it's going to take longer to get to where we want to go.
Once again, I think that we need to have a well-established long-term plan that is derived by stakeholders, and we all understand what it is, so we know what steps we can take, and we need to look at the near-term budget run out and figure out what is the best expenditure of those funds in making our way down that path, and come up with a preferred path, but understand what constraints you have and try to work within those bounds. Also, as a part of this, we need to understand what exit criteria we have for programs. That's something we don't do most often because we have a program, we want to keep funding it. But there's a time when you get to a point of diminishing returns in a program, and then you say, well, we want to make these next steps, so you free up those funds to go to those next steps. So there can be logical paths.
So also the willingness to cancel something once it's either lived its life or not going anywhere.
So that way you can invest in what comes next.
All right. Thank you, Mr. Chairman. Yield back.
All right, thank you. At this time, we're going to go into a second round of questions if there's no objections. None being heard. My first question is, since we've been talking about an asteroid retrieval mission, we've also been talking about how we're going to get back to Mars, and the moon seems to be, I guess, the majority consensus would be a good first step in that direction. My question is: are you aware of any other countries that are trying to get to the moon right now? And if so, what countries could they be? And what are their expectations? What's driving their lunar mission? And that's for everyone. We'll start with Dr. Friedman.
Well, Russia has two lunar missions they're planning in this decade, but they're both robotic, and they, other than that, vaguely talk about humans going to reinvigorating their manned program with a future lunar destination, but no active program going on in that. I believe no country has a human program to the moon. There's talk about Russia, there's talk about China, but they don't have any human program, and they're a long way off from doing that.
Well, as a matter of fact, there's a lot of the new discoveries about the poles of the moon have been discovered by a fleet of international lunar orbiters in the past 5 years. I was involved in the Indian Chandrayaan-1 mission. We flew a payload on that mission to map the poles of the moon with radar. The Japanese had an enormous satellite that orbited the moon and mapped it, the Kaguya. China sent 2 spacecraft to the moon. Orbiters are getting ready to send a lander this year, I believe. ESA has sent spacecraft, the European Space Agency. There is a lot of international interest in the moon. In terms of human missions, there was a great deal of interest and support in the European community for our lunar effort before it was canceled. A lot of them were very upset by that. I have a lot of colleagues in ESA and European countries who really didn't understand why the moon was just discarded without any thought or any debate. And yet they're still interested in the moon. They see the value of going there. They still want to go there with people. The other big player is China, and they clearly have a vigorous lunar program. They have a vigorous manned program. Clearly that's on their strategic horizon. I don't know what their ultimate goals are. I suspect at this stage it's largely to show they can do it like we did it 50 years ago. But if they can see the value of going back to the moon, just like anyone else here can.
I think Dr. Spudis has done an admirable job of summarizing the robotic missions to the moon taking place lately. Basically, everybody's doing it. There's enormous interest on the part of all major national space agencies, and I have nothing further to add with respect to, I have no particular insights regarding the plans of other space agencies for human exploration of the moon.
There have been discussions since about 2006 with 13 other space agencies with NASA in developing lunar objectives and participating in that. And in fact, about a year ago, I was on a committee where Russians came in and proposed that U.S. join with them in leading lunar exploration, human lunar exploration. I think there's very widespread support and interest in lunar exploration, and I believe a lot of our international partners are looking for us to be leading it.
Well, I definitely agree that our international partners look to us for space leadership. Now, hopefully, in the days and years and decades to come, we'll be able to provide it. Now, for example, if one of these countries does achieve human lunar, mission, and it's, say, perhaps it's China, and they create some kind of infrastructure on the moon, and the United States or our international partners have no participation in this, do you see any concerns that them having infrastructure in the United States and NASA not having any infrastructure is that a warrantable question? And we can just go down the line if anybody wants to volunteer.
Okay. The United States and the Soviet Union spent nearly $300 billion of today's kind of money translated to the past on missions to the moon. As soon as they got there, they quit. As soon as the United States got there, they quit. And there's been very little drive either in the science community or technical community to spend anywhere near those kinds of sums of money. I don't believe the Chinese will find any more gold on the moon than the United States or the Soviet Union did.
Well, we didn't know that at that time that there was gold on the moon. And the gold is at the poles, and it's in the form of water, which is the most useful commodity you can have to create capability in spaceflight. Now, I don't think it's something that having the Chinese going to the moon is something we should worry about, but it might be something to worry about if we're not there as well. Because fundamentally, if you're on the frontier and you're the only one doing something, then it's your worldview, your political economic system, your values that determine the values on the frontier. If we're not there, whose values will be determining that?
If we all agree that our long-term focus is Mars, and getting humans to Mars in a logical, stepwise fashion is the goal of our human spaceflight program, I see no particular concerns one way or the other with the Chinese going to the moon. I don't think that measurably affects our ability to do what we really want to do, which is send humans to explore Mars.
So one point on this is that great nations have always explored, and if China is going to the moon and we're not, and we're muddling around somehow, we are not going to be leading. And so I think there is a point in all of that. I think the United States should aspire to be leaders in space exploration.
Well, thank you. And since this is going to be our last round of questions, I'm going to take a little liberty with time, and I encourage my members to do the same. This question is for Mr. Cooke and Dr. Friedman. The Keck study proposed the use of advanced Hall thrusters for the mission concept as opposed to other forms of solar electric propulsion. What advantages would Hall thrusters offer that other types of thrusters such as Vasmer do not? Dr. Friedman or Mr. Cooke?
Well, this is a little bit out of my expertise, so I have to relay what others have told me, and that is that both the efficiency and the availability, the Hall thrusters having been used in space and now being developed and easily scaled up for this kind of a mission, Vasmer is certainly the kind of thing we should look to in the future when we get to the surface of other worlds, and certainly on Mars missions. But I think for the fact that we want to do this mission in just 3 or 4 years, Hall thrusters are here now and they're available, and so they're efficient enough they can be scaled to the right power level now.
I believe that Hall thrusters probably have the most experience in terms of electric propulsion. I actually used to fund Vasmer when I was at Johnson Space Center, and it certainly is very interesting technology and uses more readily accessible fuels than xenon that's required for electric propulsion. The question I have is have we by default somehow made a decision that electric propulsion is exactly the right way to get to Mars? There's also nuclear thermal propulsion, there's nuclear electric. We do need high efficiency propulsion, but I think we're using electric propulsion in this case because it's most readily available and it's in the form of Hall thrusters. But I'm not sure that the decision or discussion has been made, or the arguments made that that is absolutely the right propulsion technique for Mars, eventual human Mars exploration.
I now recognize Ms. Edwards.
Thank you, Mr. Chairman, and thank you for allowing this to go on a bit, because I think this is really the core of what it is that we've got to come to some agreement about over these next several weeks. I think it's been a shame that NASA as an agency and the industry has not had the kind of concerted direction both from the Congress and from various administrations that really is appropriate to the task that's in front of the agency. I shared Dr. Squyres' concerns about, aligning the budget and the workforce to the work that we're charged with doing. I think it's been quite unfortunate that the agency's been put in a position of having a lot of ideas thrust into its basket and none of the money that's required to perform in the kind of way that we need it to. And so, Dr. Squyres, I know that you talked about the importance of human exploration and how that can serve the task of galvanizing the collective spirit of all of us that then will allow for the match of the money with that spirit and excitement. And so I appreciate that. So I want to explore what's going on with SLS and Orion. Because, Dr. Squyres, you indicated in your statement that no human-rated launch system in NASA's history will fly as infrequently as that projected for SLS and Orion. And the effect of such a low launch rate, as you stated, would make it difficult to maintain program momentum and to keep flight teams sharp and mission ready. And Mr. Cooke, you indicated in your statement that SLS and Orion are essential to any human spaceflight strategy. So I wonder if you can comment about how funding to date, which has been lower than what's been authorized, has impacted your position on this, and if SLS and Orion are critical regardless of the interim strategy, aren't we putting NASA behind the 8 ball by not adequately funding SLS and Orion?
I'm deeply worried about this, as I noted in my written testimony. If you look at the current plans for SLS and Orion, they call for an Orion flight, no crew on board, in 2014, launched not on SLS but on a Delta IV Heavy to go far from the Earth, come back and re-enter and validate that part of the system. Next, we hope in 2017, would be another flight, again, with no crew on board. And then finally, the first flight with an actual crew on board would be 8 years from now, in 2021 at the earliest, to probably orbit the moon, which is, I think, as I said, a logical next step. And then a flight rate after that that's maybe something like every 2 years or so, as we can afford to do it. If you look back at every human-rated flight system that we've ever had over NASA's history, none has flown so infrequently, and I'm deeply concerned about this. You can quibble all you want about whether SLS is the right design, whether Orion is the right design, but those decisions have been made. What I now see is a program that is not funded at an adequate level to allow that system to be proven out at a logical pace. And that's why I beg of you as a committee not to pile more objectives on NASA beyond what they're already trying to do, because they don't have enough money to do what they're trying to do now.
So if we came to a conclusion that Mars is the next ultimate destination and we need a launch vehicle, wouldn't it make sense, given that we know that's what we need, to make those investments that we have to make to keep us on a pathway, but to do it in a way that ensures that, forget the 8-year path, that there are some number of events, of activities that ensure safety and, mission teams that were able to provide the kind of support that they need and to be mission ready. It would seem to me that we would need to really, if that's our goal, that we'd really need to front load what we're doing so that we could stay on a pathway that would result in any kind of success over the next decade.
I think there are two elements. I think the first element is, as you say, to more adequately fund SLS and Orion so that they can be developed and proven out on a pace that really supports, I think, a safe pathway towards developing these cislunar orbit capabilities that we've talked about as the next step. And the other is that in parallel with that, begin to sensibly and aggressively pursue international partnerships that may provide other pieces of the puzzle. I stress, however, that if we intend to involve international partners in a deep, meaningful way in this adventure to Mars, we need to recognize that those international partners should have a seat at the table when it comes to negotiating what the steps beyond lunar orbit ought to be.
Mr. Cooke?
I think you're definitely on the right path. Once again, the capability, for instance, for SLS with its capacity, it's not only just lifting mass, but it's also volume of payloads and diameters that you need for the kind of human spaceflight elements that we're going to launch down the road. And the deep space crew vehicle is has capabilities that are incredibly important as well. The flight rate is dependent and is driven totally by funding at this point. They're going through the development, which is a cost, but then the recurring units that you get to when you actually start flying missions, of course, they're expensive. So the flight rate in itself is driven by funding. And I'll go back to a point I made earlier. The fact that they definitely need more funding. I also believe that starting with inflation, because the effect of a flatline budget with no inflation increase means that your buying power is decreasing and it's compounding interest. So as you work down the years, your buying power is actually going down. You're able to afford less and you're flying less. And so the inflation aspect of the funding is a first step in that discussion.
Thank you, Mr. Chairman.
I now recognize Mr. Posey.
Thank you, Mr. Chairman. In the last 2 decades, we've had 24 or more programs to nowhere. Programs that were started under one administration or one Congress and canceled or funding stopped by the next or another. And I think one of the biggest fears that we all have is that we'll have more of those, that whatever direction we ultimately agree to go in tomorrow, that the next day or the next Congress or the next administration might decide to cease and pivot into another direction, which Constellation, for example, was a wasted $9 billion. Congressman Culbertson has proposed a Real Space Act that basically would set up a board of directors comprised of astronauts, eminent scientists and such, and that board would appoint an administrator for a term of 10 years. I don't know, it's a rolling 10 years how they'll do it, but try and give some sustainability, some continuity to our space assets and our aspirations and our programs. And I realize, nobody in the near future is going to figure out how to make chicken salad out of chicken manure, but I wonder how you feel Culbertson's plan would work in reality, if you think that would be part of the answer that might help us sustain our programs. And we can start, Mr. Friedman.
Well, I'm not sure that is a magic bullet, but certainly we all want stability in the program, and anything that the Congress can do to add to that, which of course means would they really be giving up their year-by-year funding authority on programs. I think the key to sustainability really relates also to your first question, which is that public interest. If the program is exciting and bringing back results while it's undergoing, not some distant future, but something that we can do in the current decade and the next decade, and setting distance records and speed records and new accomplishment for human spaceflight, learning new things at other worlds, that's the only way we can sustain a space program. And to me, that's going to be the key, to have a publicly exciting, interesting program.
Thank you. Yeah, I would certainly agree with that, in the sense that regular milestones on short time scales are critical. You need to craft a program that provides payback that can be seen under reasonable lengths of time, 5 years, 4 years, something like that. If you don't have the program structured that way, you're trying to bite off too big of a chunk. I need a giant 50-ton lunar lander, and I got to have it by this date. You're not going to go anywhere. You're going to consign yourself to future programs to nowhere. So what I've tried to do is to look at this from a systems point of view. How can I craft a program where I use small pieces? Each one is not particularly expensive in itself, but can be operated together as a complex system. And I think that can be done. And one of the values of going to the moon is that it's close enough to where you can do that. You can actually use robotic systems to create bigger, complex systems out of small pieces. So that gives you the ability to start returning regular progress on very short time scales. And I think that's the key to long-term sustainability.
I'm not personally familiar enough with Mr. Culberson's proposed plan to comment on whether it is the key to maintaining program stability.
No, not the key. No program's perfect, but just, you know, your initial thoughts.
Well, I agree with the previous two speakers that establishing and maintaining stability in this program is critically important. And while the money that gets wasted is a big problem, I think another very big problem has to do with squandering our most precious resource. The most precious thing that NASA has is not SLS, it's not Orion, it's not the Curiosity rover, it's the NASA workforce and the knowledge base that they possess. And what I see when I see NASA changing direction on timescales of a few years is I see demoralization of that workforce and I see erosion of that workforce. And I am constantly discouraged when I see immensely talented young engineers and young scientists who currently work for NASA deciding that the best place for them to pursue their goals in space is someplace else. And if we cannot maintain a continuity of vision and a continuity of purpose within the agency, we are going to lose that workforce, we're going to lose that capability, and NASA will no longer be able to do what it currently can do.
Well, they did that after Apollo, and they're doing it after Shuttle, and I don't think anybody at NASA actually laid a hand on the vehicles, but all the people that did are looking for jobs now. They're out of work, and they're not going to come back when you call them to come back. It is a tremendous loss of talent and personnel.
I've read that plan that you mentioned, and I think it has merit, and it merits discussion. I go back to the fact, though, that you do need a stable strategic plan on human spaceflight as well, and then that sort of a structure could then be one you'd have confidence, perhaps, in to manage it. So I think that's important, and I'll use an example of where stability made a huge difference in a program, and it was Space Station. In the late 80s and early 90s, the funding was up and down, very much like what's going through on SLS and MPCV, Orion. And we went through a redesign. I was in the middle of all that. I led the engineering under Brian O'Connor and then Bill Shepard. But we came out of that with an approach, and we got stable funding for a number of years. And whereas the program before Space Station Freedom was redesigning and renegotiating contracts every year, we had stable funding that we were able to plan against and actually make progress. And I think without that stability and funding that we got back then, it was $2.1 billion a year, I believe, we might not have made it. And the space station is a credit to everybody who ever worked on it, because it's an incredible feat. But the stability, that is an example of where stability turned a program around, in my view.
And that was sustained by, at one time, one vote in the House.
Yes, it was, and it was right at that time. It was. Yeah.
Thank you.
I want to thank the witnesses for their valuable testimony and the members for their questions. The members of the committee may have additional questions for you, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and written questions from members. The witnesses are excused, and this hearing is adjourned.
Thank you very much, Mr. Chairman.